Exercise 8.2 for doing question number 11 to 20. Using the comparison test, investigate convergence or divergence of the series in probable 11 to 20. Now from 11 till 20 we have to use the basic comparison test here. Now starting from question number 11. Summation 1 to infinity 1 over n raised to power 1 over 2 plus n raised to power 3 over 2. For doing the comparison test, we need to just select our bn term, bn. Whatever is given here, this one will be our an. Now we need to select our bn so that we can compare our an with the bn. And also our an must be less than bn. For that purpose, let an here is 1 over n raised to power 1 over 2 plus n raised to power 3 over 2. Mostly our bn term is whatever we have in our denominator. If it is in 1 over this form, then we can take our 1 over this highest power of the denominator. That is 1 over n raised to power 3 by 2. So it will be an is less than bn here. You can observe it because here in the denominator you have two terms that are adding up, and you know that the addition of two terms will be greater than this single term. Or you can say that n raised to power 1 over 2 plus n raised to power 3 by 2 is greater than n raised to power 3 by 2 because I have just taken one term out of it. It is one term less than this side. So this side is greater than this one. Now we have here in the fraction form 1 over. So just take the reciprocal. We will get 1 over n raised to power 1 by 2 plus n raised to power 3 by 2 less than 1 over n raised to power 3 by 2 here. So this one is our an and this one is our bn. So it will be, now observe this one. Summation n is equals to 1 to infinity bn is summation n is equals to 1 to infinity 1 over n raised to power 3 by 2. Now observe this power. This power is 3 by 2, that is equals to 1.5 greater than 1. So it is a p series, and you know that if p is greater than 1, then your series is convergent. So summation n is equals to 1 to infinity bn is convergent. If your bn is convergent, then this implies that your given an is also convergent. That is summation 1 to infinity 1 over n raised to power 1 by 2 plus n raised to power 3 by 2 is also convergent series. Now your an equals under root n over 1 plus n here. Now how you can choose the bn out of it? In the previous one we were having 1 in the numerator. We just took 1 over the highest nth term, the highest power of the n. Here we will also consider our numerator because we have some function in numerator as well. Numerator divided by with this highest variable. So you will be have bn equals to under root n over n here. That is equals to 1 over under root n. So you can just here observe that your this term bn summation n is equals to 1 to infinity 1 over under root n. That is equals to summation n is equals to 1 to infinity 1 over n raised to power 1 by 2. This one is diverges. Since it is diverges, so this implies that your given series an is also divergent. And if you observe that limit n approaches to infinity an over bn, that is equals to limit n approaches to infinity. What is your an? Under root n over 1 plus n divided by your bn is 1 over under root n. This will be equals to limit n approaches to infinity. This thing will become n over 1 plus n. And that is equals to, after applying the limit, you will get here 1. That is not equals to 0. In your limit comparison test, if it is not equals to 0 and your Bn is divergent, this means your An is also divergent. Your limit comparison test tells that you have 1 in your limit An over Bn that is not equals to 0. So check your convergence and divergence of Bn. It is divergent, so it means your An is also divergent. So you will write it like, since summation n is equals to 1 to infinity, Bn diverges. Therefore, the series summation n is equals to 1 to infinity An also diverges. Now your An term is 2 over under root n plus 1. Bn will be equals to, this is a constant, so just don't consider it and take 1 over this highest variable power, 1 over under root n. So Bn term is 1 over under root n here. Limit n approaches to infinity, An over Bn, that will be equals to limit n approaches to infinity. Here An term is 2 over under root n plus 1 divided by Bn is 1 over under root n. So this will be equals to limit n approaches to infinity 2 under root n over under root n plus 1. You can write it like limit n approaches to infinity 2 under root n over, take under root n common, 1 plus 1 over under root n. This under root n and under root n can be cancelled out, and after applying the infinity, this term goes to 0. You will get here 2. And this is not equals to 0. Since it is not equals to 0, so your both Bn and An will behave alike. Both will show the same behavior. And now you know that summation 1 to infinity Bn diverges. This implies that summation 1 to infinity An also diverges. Both series will have the same behavior because this limit is not equals to 0. Question number 14. Summation 1 to infinity 1 over n raised to power n. If you observe that your n raised to power n is greater than 2 into n. N raised to power n is always greater than 2n for n is greater than 2. So if you take the reciprocal of it, you will get 1 over n raised to power n. That will be less than, the sign will become opposite because you are taking the reciprocal, 1 over 2n, and this is also for n greater than 2. But you know that sum of series from 3 to infinity, because here you are writing it like for n is greater than 2, so I am taking it from 3 to infinity, 1 over 2 raised to power n is convergent. How it is convergent? If you just put the values here, you will get here 1 over 2 cube plus 1 over 2 4 plus 1 over 2 5 plus up to so on. Find out the common ratio. The common ratio will have, you will have here 1 over 2 out of these two terms, and out of these two terms you will again have the common ratio 1 over 2. So if you observe, your common ratio is same here. If your common ratio is same, so this is your geometric series, and normally the geometric series are convergent. This is convergent due to being a geometric series. Therefore this summation 3 to infinity 1 over 2 raised to power n is convergent. And by using your theorem 8.16 part 4, You can say like summation 1 to infinity 1 over 2 raised to power n is also convergent, because adding some terms to a series will not alter its convergence or divergence. You can add some terms to the series and the convergence and divergence will not be changed. So I can write it like from 1 to infinity 1 over 2n is also convergent here.